Hello. In this video, we're going to take a look at the relationship between standard form and vertex form for parabolas or quadratic functions. We've seen standard form before. We've also seen vertex form in terms of graphing it, but today we're actually going to talk about how to convert something from standard form to vertex form. It does involve the process of completing the square, so it's very similar to that. If you liked using completing the square to solve quadratics, you'll see it's very similar. And you'll probably like this lesson as well. So, best way to learn anything, let's jump right into an example. In this case, we're given a function. Notice it's in that trinomial ABC standard format. We want to ultimately write it in vertex form. We want to then identify the vertex and classify it as a maximum or a minimum. So we can kind of answer that right away. We could see here it is a negative function, but we'll get back to that later on. So first, writing it in vertex form. This is procedural, step by step in some ways. How you visualize it or how you conceptualize it is up to you, but these are the steps. You first, just like with completing the square, you want to verify or make a equal to 1. In this case, it is not. There's a negative sign in front of the x squared, meaning we should divide it out. Okay, I'm just going to rewrite it. So basically, I'm dividing everybody by a negative 1 here. This is allowed since I'm doing it on both sides. And it's going to help me with my step of getting a by itself. Or getting a equal to 1, I should say. So this is going to be negative 12x plus 20. So the one thing that's different about completing the square for vertex form, when we were doing completing the square just to solve things, we didn't really care if we did something, it just kind of went away. We'd say, all right, divide out of 2 and it's gone. Divide out of 4 and we forget about it. Here, notice, because it is a function, it's equal to g of x, we're not losing things. We don't just like throw things out or divide them. So they are kind of preserved. And that adds a step at the end where we kind of want to put it all back together again. So it's harder in that aspect, easier in the fact that we don't actually have to solve anything. Okay, step 2 is going to be to move the constant over. So I'm going to move that 20 over. And you should recognize this step from completing the square. We move the constant over. And the next step here is going to be very similar as well. We actually want to complete the square. On the right, what's that missing number that's going to be able to kind of fill in the box, so to say? So if we want our little visual here, I have an x squared. I have negative 12x's, so we could think of those as two congruent rectangles, each of negative 6x. Remember, you're kind of chopping that b value in half because you have 2 of them when you're foiling. And now that missing number is going to be a negative 6 times a negative 6, or a plus 36. Remember, that number you add should always be positive. Some people get weirded out with the negative signs and they'll put like negative 36 for this example. Even if you do the algorithm or the step-by-step approach, it's b over 2 squared. So just using common sense there, if you're squaring something, it should always be positive. And also verify it checks out. Negative 12 divided by 2 would be negative 6, which once again, squared is positive 36. So I'm going to add that to both sides. I'm going to do the math here just to clean things up. So that's going to be 16 plus 16 now on the left. And on the right, I have a perfect trinomial, which means I could write it, the whole point of this, in that format of x minus 6 squared. Look back at your box as well. We drew a box that we completed that was x minus 6 by x minus 6, or x minus 6 squared. Basically, we're factoring this. And it is repeated, so we could write it as squared. Okay, and we've completed the square, so we've achieved what we wanted. We ultimately wanted something in vertex form where we have that bubble squared, like we saw on the title slide here. So we have that. Now, what I mentioned earlier, we just have to kind of put things back together again. So I'm going to move the constant back to the right. So this is new, because usually when we start like solving here, now we're just kind of like putting it back together again. And be careful, you might want to kind of circle this right here and say you're done, But remember, this was negative g of x. The first thing we did was divide that negative. So now we have to kind of put it back there. So I'm going to redivide, and each of these gets divided by negative 1. And my final answer, I'm just going to squeeze in here. So finally I have it in that g of x format. Okay. With the bubbles squared, if you're dividing it by a negative, the negative sign simply just goes in front. You don't want to do this, like distribute it inside there or something like that. Just simply put a negative sign in front. It's like saying, hey, this bubble is negative. This binomial is negative. And the negative 16 divided by negative 1, you could hopefully assume is positive. Kind of a bad place for a page break there. Plus 16. Okay. What I like about Vertex form, or this topic, this lesson, if you will, it's very easy to check. What do I mean by that? You shouldn't be unclear whether you did this right or wrong. If I type this into my calculator and type in this blue box, this original question to my calculator, what should be true about the graphs that I see? Well, we're not changing anything, so literally we should only see one graph, or depending on your calculator, the same graph traced over twice, or traced over itself. There's a few other things you can go about. We could actually like square out the x minus 6 and see if it checks. That would be more of like an algebraic approach. Check the vertex to make sure it matches with both. It's very clear whether you did this right or wrong. So it shouldn't just be like, oh, I hope it's right. So that's a good thing about this because it can be a little confusing. We were also asked to identify what the vertex is. So now that it's in vertex form, I just want to be careful with IHOP here. This is my x value, which the opposite of that should be positive 6. And this is my y value of the vertex. That's a good thing about vertex form. You can pick it out right away. And this would be a maximum or minimum. We're going to classify it as a maximum. How do we know without even seeing a picture of a graph? If you remember, I mentioned it right away. The function itself is negative. We have a negative sign in our vertex form. We have a negative sign here. This is a downward facing parabola, meaning that middle symmetrical point is a peak or a maximum point for the graph. It's the highest y value, the largest y value that the graph contains. So this is a maximum because it is a downward facing parabola. Okay, this was completing the square to convert something from standard to vertex form. Hopefully this video helped. The steps can be a little tricky, especially if you have to divide out the a value, which we did here. This would be kind of as tricky as you would see a problem with the negative sign in front. Oftentimes it is just x squared, so you could actually jump right into your steps of moving the constant over and ultimately completing the square. Okay, so thank you guys for watching, and hopefully you found this helpful. Let me know if you have any questions.